Then we're going to enter the most important part of today's lecture. Balance the redox reaction. Question you're going to encounter in your homework. Okay, it's going to give you this reaction and then ask you to actually balance the reactions. And in your homework, it's going to ask you what is the coefficient in front of a certain chemical. So how do you solve these balancing questions? So here I summarize all the steps that you need to know. So these are the steps that we are going to use. So in your questions, it will always tell you you are actually in an acidic solution or basic solution. So the first thing is actually you need to identify you are in the acidic or the basic solution. The reason that is important is because when you balance these equations, the step is to balance the atoms. Then depending on your acidic solution or basic solution, the things you add into your equation will be different. So here I will just quickly summarize the things we're going to do. If you have acidic solution, if you want to add in protons to balance your atom, you use H+. But in basic solution, you use H2O. If you want to add in oxygens, in the acidic solution, you use H2O. And in the basic solution, you use 2OH-. So these are the things that you want to actually memorize it. Once you identify what kind of solution you have, the first step is actually write out the two half reactions. Second step is actually once you have two half reactions, you balance all atoms using either H2O, H+, or OH- if you have basic solution. And then once you balance all the atoms, then you balance the charges using electrons. So let me highlight the things that we're going to add in. And then once you balance the charge with electrons in both half reactions, then you balance the total electrons you have in the two half reactions, and then you're just adding them up. So it sounds very complicated, but I think if we do one example for you, then you will feel a lot more comfortable. Balance the following reactions in the acidic solution. When we say acidic solution, it means if you need protons, you use H+. If you need oxygens, you use H2O. So the first step is actually you want to write out the two half reactions, right? So again, you need to actually identify the oxidation number of each species first. So here you should see that Fe is 2+, right? MnO4-, that means your Mn is +7. Once you form the product, your Fe now become +3. And then Nn2+ will be just 2+. So by doing this analysis, you're going to write out your two half reaction, right? One is LoRa, one is your G-Rock. Okay, so who is actually your LoRa? Whose oxidation number increases? Fe, right? So you know you need to write Fe2+ is going to become Fe3+. Okay, that's actually the half reaction for your LoRa. And then the other half will be your MnO4- is going to become your Mn2+. So let's actually the step number 1. Write out your LoRa and G-Rock. So what is step number 2? You're going to balance all the atoms, right? So if you look at LoRa reactions, is the atom balanced? It's balanced already, right? You have one ion on the left, one ion on the right. For the LoRa, step 2 is actually done already. How about your G-Rock? It's not balanced yet, right? You have more oxygens on the left. So you need to actually balance the oxygen. To balance the oxygen in the acidic solution, you add in what? You add in H2O. How many H2O do you need to add in? 4 H2O you need to add in, right? You have 4 oxygen here, right? So you know you need to add in 4 H2O on the right. So you balance your oxygen. But at the same time, you introduce what? You introduce the hydrogen. So to balance the hydrogen, you need to use H+. Therefore, you need to add AH+ on the left. So up to this point, you also balanced your G-rock. Okay, so let's actually step number 2, right? Step number 3, you want to balance the charge of your LoRa and G-rock. For your LoRa, on the left is 2+, on the right is 3+. Then you need to add in 1 electron, so that both sides will be 2+. For the G-rock, let's look at the total charges you have. MnO4 minus, therefore, for this species, overall, it carries -1 charge. You have 8 protons, that means it carries a +1 charge. Therefore, for the left-hand side here, you totally carries 7 positive charge. How about on the right? This is only charged species, right? Therefore, on the right is actually +2. Left-hand side is +7. Right-hand side is +2. You want to add in electron to balance the two, right? Therefore, you need to add in 5 electrons on the left-hand side, so that it will also be +2. Step number 4 is that, okay, once you put in those charges for your LoRa and G-rock, you realize on the top you only generate 1 electron, right? At the bottom you need to take 5 electrons. They are not balanced. What you need to do is multiply the things on the top, okay, to match the electrons that you're going to give at the bottom. So in this case, you need to multiply by 5. So in the end, what you're going to have is actually 5Fe2+ become 5Fe3+, and then totally you have 5 electrons given out. And then once you do that, then you can just add in all up. So once you adding up, you are going to get 5Fe2+ plus MnO4 minus plus AH plus 5 electrons. That's going to give you 5Fe3+ plus 5 electrons plus Mn2+ plus 4H2O. And then you will see that 5 electrons is going to cancel out. So the final answer you are going to get is 5Fe2+ plus MnO4 minus plus AH plus. That give you 5Fe3+ plus Mn2+ plus 4H2O. And then in your homework, it will ask you what is the coefficient, for example, in front of H2O. Then you need to select the answer of 4. The key is actually you follow these 5 steps so you can actually get down to the final equations. If you go to next slides, there's actually another examples, right? But it's actually asks you to balance the reaction in the basic solution. So the only difference of lab questions to this one is that the way you balance your atom will be different, because right now it's in the basic solution. So if you want to add in protons, you use H2O. If you add in oxygens, use 2OH minus.